Okay, so today we are going to finish up chapter 1. We are going to learn how to classify polygons. So first of all, we're going to identify or define what a polygon is. If you know your vocabulary and you know about prefixes and suffixes, the prefix here, poly, means many. So polygon means many angles. So a polygon is a closed plane figure formed by coplanar segments, which are called sides, such that all three of these things are going to occur. And these three things are: each side must intersect exactly two sides, one at each endpoint. Second thing, no two sides with a common endpoint are collinear. And each endpoint of a side is a vertex of the polygon. All right, so now, based on those three characteristics here, we're going to identify which one of these is a polygon. So let's go ahead and look at the first one, figure A. Is that figure a polygon? Yes, it is. Okay? It satisfies all three conditions. However, figure B, this one is not a polygon because the sides right in here, it's not closed. So because the sides are not intersecting two other sides, that would be the reason why it's not a polygon. Letter C figure. Okay, this one also is not a polygon. And the reason why is we couldn't have like a collinear point. So like, for example, if I take this segment right here, notice how it's got this point here and this point here. Okay, so if you wanted to say that, you could say that it intersects too many sides. So because it intersects here and here. Or you could say sides intersecting more than two sides. Can only hit it once. So like we couldn't have a side and then have a bunch of points on it, like this one. That's what makes it not a polygon. Now the next one, notice nothing goes through. They're all connecting at two other sides. So figure D, yes, this one is a polygon. And then E, yeah, it's hitting it at it's hitting all the sides, but E is not a polygon because it's not closed. So it's not closed. You could also say sides not intersecting at both ends. So it's not a closed figure. So that would not be a polygon. The next thing we're going to talk about is convex and concave. Next, we're going to talk about a convex polygon. And a convex polygon is no line that contains a side of the polygon contains a point in the interior of the polygon. So what I mean by that is, let's say I were to, like in this one in the middle, extend these lines. Notice the line does not go inside the polygon. Same thing on this one. If I were to extend these sides, notice that my line never goes inside my polygon. And I can do that with every single side here. an example of where it would go inside, let's say my polygon looked like this. And let's say I were to extend this side. See how if I extend it, it goes inside. And on the next slide, we're going to name that. So this one would be not convex, but we're going to name it, it's going to be concave. So if you notice, it looks like the side's caving in. So on all of the ones that are here at the bottom, these three figures, these are all convex polygons. Because if you were to extend the sides, none of the sides go into the interior of the polygon. Next, we have our concave. So again, if you were to extend the sides of your polygon, you're going to find that it would go in. Now, it doesn't have to be all of the sides. Soon as you find one, if you were to extend that side and it goes inside to the interior of the polygon, it becomes concave. So again, it looks like one of the sides is caving in. So if that helps you identify when it's a concave, one of the sides will be caving in. So concave and convex, those are your two types of polygons. Next, we got to go up. Next, classifying the polygons. They all have special names based on the number of sides in each polygon. Now, most of these you should be familiar with. The three-sided polygon is a triangle, 4 is a quadrilateral, 5 a pentagon, 6 a hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 is a dodecagon, and anything after that, or even the 11, what you're going to see as they're just going to write the number. So like for an 11-sided figure, you would take the number 11, and then you would just put a dash and write GON. That would be for 11 sides. Okay, it doesn't have a special name. If it's a 100-sided figure, you would just do 100 dash GON. The ones that mix people up are 6 and 7. I remember 6 as the hexagon because the word 6 has an X in it. So does the word hexagon. And then 7 is heptagon. I remember 8 like an octopus. An octopus has 8 arms. So an octagon has 8 sides. Nonagon, it sort of looks like it's spelling out the word 9. It's got an N and an N. For 10, think of a decade, 10 years. So a decagon, 10 sides. So those are the classifying. So you need to memorize these names. Next, we're going to talk about more specific names for polygons. So we have equilateral, equiangular, and regular polygons.
Thank you. Thank you, guys.
So an equilateral polygon is when all sides of the polygon are congruent. Equiangular will be when all angles are congruent. And then when you see the word regular in front, like a regular hexagon or a regular pentagon, this tells me that all sides and all angles are congruent. So both sides and angles will be congruent when you see the word regular in front of the polygon name. So again, you might see regular pentagon. So if you were to have to draw yourself a picture, know that when you draw the picture, you need to draw it with all sides the same length and all angles the same measure. So the word regular in front will be important to us when we're solving some of these questions. Then the next example, let's go ahead and identify these polygons. Okay, first of all, we're going to tell if it's a polygon, and if it's a polygon, you're going to tell me if it's convex or concave. So for letter A, is this figure a polygon? No, it's not. Okay? Because of this side in here. You can't have that. It's got to intersect exactly two sides. This one, B, is this a polygon?
Yep.
Yes, it is. Okay? Is this polygon concave or convex? Convex. None of the sides are caving in. Now, C, is this a polygon? Correct. This is not a polygon because this is a curved side. A polygon cannot have a curved side. It's like an arc here. Okay, so no curved sides on polygons. So that one is not a polygon. And then example D, is that a polygon? Yes, it is. And is this concave or convex? Okay, it's concave. Because if I were to extend this side, see how it goes in? And you could think of this as caving in. So this is a concave polygon. Good. Next example. All right, so this one it says classify the polygon by the number of sides. So you're going to count how many sides and you're going to give me the special name. Then you're also going to tell whether the polygon is equilateral, equiangular, or regular. So the first one, let's count the sides. It's got 1, 2, 3, 4, 5, 6. What's the six-sided polygon name? Hexagon. Good. Now, so we're going to look to see, notice all angles have the same little congruency mark and all sides have the same congruency mark. So when all sides are congruent and all angles are congruent, this tells me that this figure is a regular hexagon because all sides are congruent and all angles are congruent. Makes it regular. Example B, what kind of figure is that? How many sides do you count? Count 4, right? Making it a?
Quadrilateral.
Beautiful. Quadrilateral. Now, notice if we go to look at our angles, they don't have all the same markings, and neither do the sides. So this one is not going to be equilateral. It's not going to be equiangular or regular. Okay, so this one is none. It's not any of the three. The next one. What kind of polygon is this? How many sides do you count? There are 12 sides. So this is a dodecagon. Okay. Then we're going to look at it and notice all the sides are the same. So we would say that this is equilateral. This is a concave polygon. All right, we have one more example. So here it says a table is shaped like a regular hexagon. The expression shown represents side lengths of the hexagonal table. Find the length of a side. The key word in this whole little paragraph is the word regular. So because it says that this is a regular hexagon, you're welcome. It's a regular hexagon. This tells me that all sides and all angles are congruent. So what I can do here is I can set this equal to this because these two sides are congruent because it's a regular hexagon. So I'm going to set 3x plus 6 equal to 4x minus 2. I'm going to combine my x's. 6 equals x minus 2. Add the 2. So x equals 8. So to find the length of the side, I'm going to plug in 8 for x in either one. It doesn't matter. So if I plug it in here, 4 times 8 minus 2 gives me 32 minus 2, and it's 30. If I plug it in right here, 3 times 8 plus 6, 24 plus 6, and notice either way, I get 30 for the length of my side. So on the test, make sure that you've memorized all of those polygon names. Understand what it means to be concave and convex. Understand when it's equilateral, equiangular, or regular. So make sure you understand all the vocab terms here. Right, so you do have homework for section 1-6 tonight. It is on Canvas. When you come in tomorrow, you're going to do the warm-up for 1-6, and then we're going to go over the answers to the homework for 1-6. Over the weekend, I'm going to be posting a review, and you're going to be doing the chapter review from the textbook for the test for Tuesday. Then on Monday, we will review, and then again, your first test will be Tuesday.